Hello, I'm Dr. Ron England, and I'm going to take you through this series of lectures on something that I call the XML property object. And what the XML property object is an abstract class in written in C Sharp, which allows you to inherit from this class. But the big thing about this class is it has the capability of serializing itself to XML and deserializing itself from XML. So it can make an XML representation of itself, and it can actually take the XML of itself and populate all the properties of itself from that. So I'm going to show you how this class actually works. Well, there's a few pieces that go with the class that actually aren't the class, but go with it. One is this thing is I've created an interface, an XmlPropertyObject, because I have different classes that work together to make the XmlPropertyObject work. One of those classes is a database wrapper, and the database wrapper uses the interface, the XmlPropertyObject, to know how the XmlPropertyObject is going to be used in it. So in other words, and the interface is simply describes what the implementation of this class is going to be. So it has some properties like ID, name, description, and owner, and it has the very important methods to be XmlSerialize and XmlDeserialize. So I also have a second interface that I have here because I use my XmlPropertyObject with user controls and other types of input and output objects. So I create interfaces for those too. That's going to be actually in other lectures where I describe how I use this interface and how the XmlPropertyObject works with those interfaces. But let's kind of delve right into this concept of the XmlPropertyObject. And note that in my definition of the XmlPropertyObject of my class, it is an abstract class, meaning that it doesn't actually do anything of itself. It is meant to be inherited by other classes. So it gets all the capabilities of these other all these other classes when they inherit, get all the capabilities of the XmlPropertyObject. And this shows that it actually implements the interface XmlPropertyObject, but it actually has more methods, and so in other words, the interface doesn't have all the methods and properties that are implemented. It shows the ones that are necessary for the interface for different objects that are using it. So what you can see here, I actually have, I said that we define these objects, ID, name, description, and owner, and here they are actually defined. I have three constructors, one with no arguments, one with an argument called ID, and then another argument called XML. And what this does is if I instantiate this object with the ID says, okay, well, here's the ID of myself. The ID is the ID within the database because I store these XML strings in a database, and each one has actually got an ID associated with it. And select, the method select, will actually go and get that specific object out of the database, and when it selects it actually then deserializes. Or I can actually create it with an XML string, and in that case I call the XML deserialize. Okay. Also, as part of the XmlPropertyObject, it has to have knowledge of itself. So in other words, it has its class name and it has its short class name. What I mean by class name, if you do a class name, when we say in this case full class name, if I do return this get type and bring it to a string, it's actually going to have the fully qualified class name. So in this case, that fully qualified class name will actually be going up here and looking at the namespace will be smada2013.appcode.xmlPropertyObject. So it has the inclusion of the entirety of the namespace and the class name. However, in many cases, I don't want to actually use the full class name. I just want to use the class name XmlPropertyObject, or because it's an abstract class and it's going to be inherited from other classes, the name of the class that inherits. And we're going to show that some inherited classes and other methods in other lectures also. So these are all helper methods, but these are ones that you should be able to look at and say, well, that's kind of interesting. Here's the full class name. Here's how you get the class name, the full class name of an object within the object. This being the qualifier get type toString. And then the short class name essentially removes everything to the left of the dots. Okay, that's it. Because the dot notation differentiates the class. So Let's look at this concept of being able to serialize a class. And what I mean by serializing a class is I've got the ability to convert it into an XML string. So to do this, the first thing I do is I want to create what this XML is going to look like. Now, the best way to do this is probably to show you a class that inherits from this and show you how this works. So let's go ahead and start up the program. Okay, here you can't see this. Here's my interface here. I'm going to make it a little bit smaller. I'm currently logged in, and I'm going to go to the Tools page. Every object that I work with in here actually I work with in this program is an XML property object because they all have the ability to say themselves. And here's an object called a watershed, and I'm going to bring up the editor of the watershed. And in my interface here, I have two views. I have a table view and an XML view. If I click on XML view, what it will do is it will bring up an XML view, what this object's XML actually looks like. And these are all properties: infiltration method, total area, time of concentration, impervious area. Those are the names of the properties of the watershed object. And the class name is watershed. So I have class name, and then within that, and then I have closed watershed here. So that's XML. And within that, I have a listing of all the properties and then the values that go with all those properties in here. So that is an XML representation of that object. What I do in XML property object is I save this XML representation to a database, and then I can retrieve it from the database and then populate all the properties of the class with the values that I've pulled forward. That's the concept of XML serialization and XML and deserialization. Okay, so let's go back to my sample properties, and I do this by hand in this case. So the first thing I do is I get the short class name and I create a wrapper for that watershed. Okay, that's where I actually create this watershed. That was the class name there, and FC is my short class name. Now, I also now look through all the properties. This is going to get all the properties of the class. This.getType.getProperties will get all the properties of the class. So every property is going to be returned in this. And it is a return values are going to be class of type property info. So this property here, this variable property, is of type property info. So then I create this property.name. That is the property name, like infiltration method is the name of a property, and the close is the name of the property. There's my open, there's my close, and inside of it I have this get value, and I pass it the property info. Okay, in this case I pass a property info, and then I close the whole thing. So let's look and see how that works. Well, if I go over here to where I have get value property info, okay, property info is a class of type property info, okay, and I do a few things here. One is I want to bring back, okay, if this actually has any decimal places. So in other words, if it's a double or a single precision, I don't want to store it with the whole thing. I only want to store it to the precision that I have. And I actually have this method called property decimal places. And what this method does, it returns a dictionary. And in that dictionary, which for each class I actually define the values of that dictionary, it tells how many places I want each property to go to. Okay. Then I simply look to the different classes of properties that I might possibly, the property types that I might deal with, in this case double, single, and then the default, which would be everything else. Okay, I actually don't store anything as an array list, but I use this to capture information. But I do store things as a double. And let's, what happens if I do this? If the class is of type, or in other words, the property is of type double, okay, which is a double precision floating point value. If it's a class W, I call this get value with the property info in the argument places. What does that do? Well, what it does is it creates a format string and it returns the value formatted in the format string, which gives me this nice 11.0, 0.00. It gives me the format that I want for that output. Now, a few things to note here, okay, because I'm going to go over and kind of go over some of the concepts here. I have get value, and get value. But each get value accepts different arguments. This is an example of polymorphism. They all do the same thing. They all get the value of something, okay? And they return it as a string. They all return a string. So they're all the same method. However, because they get different arguments, then you've got this ability, because they do accept all different arguments, you have the ability to handle with those specific arguments how you want to get that value back. And that's an example of polymorphism, which is one of the key tenets of object-oriented programming. So essentially, what I do in this is, as I make this serialized, as I make this XML string, I use the class as the root. I use a property name as each of the XML element names, and the value of that property as the value of that XML element. And then I close the whole thing, and that allows me to store this as XML. And there's that XML, as you can see it. That is the easy part. Creating the XML is actually quite easy, and I did customize this because I wanted to make my XML be exactly the way I wanted my XML to be. Now, I also now want to deserialize. By the way, I actually have the method which does use the serializer built into, because you do have serialization objects that I do understand that they're there and available in .NET. I didn't use those because I wanted to customize the way I did my serialization. Here's the challenge, is deserialization, because it's very difficult to deserialize things into themselves. But here's what I do to deserialize. Okay, I have this method called XmlDeserialize, and what I do is I take the XML, which is this XML that you see right here, okay, and I then parse it using an X document, okay, and that's going to give me a collection of X elements, okay. Doc.root.elements will return a collection of X elements, which is each individual element within that XML. So infiltration method is going to be an element. Total area is going to be an element. Time of concentration is going to be an element. They're all going to be elements. And then I call set value. Okay, and I set the value with the name. Okay, now coming back over to my XML, the name is this. It's the name of the property. Okay, and then the value, which is going to be the XML value. That's going to be stored in the XML, and that's the values that you see inside of here. This SDS curve number, this 12.0, this 11.0. Those are all the properties. So I'm going to set the value. Now the first one that I do here is actually calling it with a string and a string. Okay, so I have a set value which accepts a string and a string. And here I actually can tell what the strings are because I give them good names. Property name and value. So what I do here is I actually create a property info from the property name. Then I make sure that I can actually write to it. It's not null. Okay, it can write. And the value is not empty. It's actually got a value that's associated with it. Then I set the value. PI, value. Okay. Well, I'm calling set value again. Okay. Calling another instance of set value. Remember, polymorphism now allows me to do this. And this is actually going to call it with a class, PI is of class property info, and values of type string. If I look down, there it is. Set value, property info, PI, value. Okay. And in this case, I created a switch so that I could handle different types of properties, but the only type of properties, all the types of properties that I'm currently handling can be handled with one statement. Okay, so I actually don't need this switch here, but I put it there just in case I would need it. So in other words, if I come up with a type of property that I need to custom handle, I've got that capability of doing it. But in this case, I just simply use the set value of the property info. In other words, property info has the ability, it is the info about that property, it has that ability to set the property. Okay, and that has a set value method of itself. Notice I use the same names. This set value is the set value of XmlPropertyObject. This set value is the set value of property info. And I also make sure that I change the type of the value to the property type that's correct for this. And this is how the set value works. It actually uses this, the class itself, because it's a value of the property is of this object, this being the current object. So the object has a property, and the property is defined as the property info class, and I set the value of it. And that allows me to do the XML serialization and the XML deserialization. Now I can also add some other error handling and other things to this, but this is the basic gut capability. Key concept. So I have the ability to serialize, I have the ability to deserialize the class from XML right into itself with this. Now I'm going to go over just a couple more simple operations here. I have these user interface methods that I've also defined that allow me to answer the class in different ways. Notice, and one thing that I did is I have these abstract methods down here called property labels and property decimal places, which return dictionaries. I am forcing myself, when I make an instance of this class by inheriting from it, to implement the method property labels and property decimal places. Also, input properties and input property values also have to, input properties is abstract and it has to be implemented also. So some of the other ones that I have, I actually implement. But if you look at the names, property labels actually allows the interface to have a nice label on each property. It's the label that goes with the property. Property decimal places is how many decimal places it is. Well, we can look at that. Let's quickly look at an example of this. I'll go to Watershed, where I've actually implemented this. And so if I'm looking at, say, property labels, well, there's the name of the property in the dictionary, and there's what the label in the interface looks like. I don't want it to be total area with, just like that. I want it to actually be something that the user can read, in this case with a set of units. So that is used to give the labels. And I actually have also it in terms of input properties. These are the properties that are used in input, and it actually has the labels also. And I also implement input property values, but I can also implement other versions of input properties if I want to have different interfaces for different things. For different, like I have different interfaces to the same object when I'm creating an interface design. That will be part of a later lecture. But you can see this public abstract dictionary forces me to implement property labels, and I'll get an error if I don't. Okay? And I also have one where I return the input property value. So in other words, for every input property, if the value is already, there is a value, it has this ability to set it. To answer a dictionary of 2 strings for those values, and I use that to populate the interface also. Okay. Last but not least, the database operations, because this all relies on a database. And in the database operations, I actually stick with the names that make sense. I have select, insert, update, and I have not implemented delete. That's one that I probably should implement, but I haven't done it yet. And what those do is they use this class called XmlObject database. Okay, XmlObject database, when you call an insert method, it looks for an XmlPropertyObject. Remember that XmlPropertyObjects implement this interface, and this just has all the SQL information necessary to insert, or in other words, not in this case insert, but to select from the database. And this is my insert. Okay, so this is to insert this object into the database. The XML data is actually saved right here in a field called XML data, and it uses the serialized version of that. Everything else going in is metadata. Short class name is the name of the class. The name of the, and remember there are properties name, description, and owner. Those all go into the database. So now we get everything into one place. Okay. Bottom line. Okay. I have a class called XmlPropertyObject, which can serialize itself into XML, deserialize itself from XML, and it can save itself into a database using this other class called XmlObject database. Hopefully this is useful. There are going to be other lectures that go with this. I am going to make the code all completely available to you. so that you can work with this. But this has got some very powerful capabilities. I use it all the time. It's one of my favorite classes that I work with, and I think it can be useful to you too. Good programming.